So now, who can tell me what is a socket? Lưu em vậy đấy.ឥឡូវណាគេអញនិយាយបានថា socket ជាអីមុននឹងយើងតមករៀនយើងទៀតអ្វីទៅជា socket វិសាលយន្តវិសាលស្អីគេជា socket ដឹងទេ Hello លឺខ្ញុំនិយាយអត់ទេហើយក៏ដាច់អ៊ីនធឺណិតបាត់ហើយ
Yeah, here teacher
ហ្នឹងហើយវិសាលនៅអត់វិសាល socket អីគេដឹងអត់ socket What is socket នេះ socket នេះបាត់វិសាលទៅណាហើយតើពន្លឺ What is socket
Yes, teacher.
What is socket
Socket is kind of technology that allow the communication.
Socket is a kind of technology that allow communication not really true it's a little bit true but not really true so anybody only one word what like last week socket is equal to what like in general when we talk about socket like what is the word that represent the socket only one word socket is only one word who can tell me the definition is very long but normally when people talk about socket they only say one word and that represents socket we don't need to say socket is a technology yeah I heard the word
endpoint
yes that's right so socket is endpoint okay very simple if you don't know what is socket you just say socket is endpoint everybody know it okay socket is an endpoint not a technology allow communicate it's very complicated but very straightforward socket is an endpoint and then we will try to answer like what is an endpoint because when we talk about socket, if you are not an IT person, you don't know what is socket, okay? Even the word endpoint is like, but normally when people talking about endpoint, most of the people know it because they learn about the networking computer, something like that, okay? So now we know that socket is an endpoint. So how about what is an endpoint when we learn the distributed system? And I show you the detail of an endpoint. Because when people reading the book, or reading the definition of something, they only tell you socket is an endpoint. But behind the scene, you don't know what is an endpoint. So now who can tell me what is an endpoint? What is the component that build up an endpoint? Mình là cái slide endpoint ហ្នឹងប្រហែលដឹងអញ្ចឹងបើសិនជាយើងនិយាយ socket យើងអត់ដឹងថាហ្នឹងជាអីគេតទៅពេលហើយបើសិនជាយើងចង់ឲ្យច្បាស់យើងនិយាយថា socket គឺជា endpoint ណាគេក៏ដឹងថា endpoint ជាអីដែរតោះនេះបើសិនជាយើងបកជាខ្មែរទៅយើងដឹងថា endpoint អីគេបាត់ហើយហើយបន្តមកទៀត endpoint ហ្នឹងគឺវាផ្សំឡើងដោយធាតុពីរយ៉ាងអញ្ចឹងសួរថាតើធាតុពីរយ៉ាងនោះអីគេមានអ្នកគេដឹងអត់
IP address and port number
That's right okay អាហ្នឹងបានគេហៅអ្នករៀនអញ្ចឹង socket is an endpoint so endpoint normally is a machine if we talk normally without knowing the behind the scene endpoint is a machine is a computer is a machine that we want to communicate so that is called endpoint like another point and another end of the point something like that so if you want to communicate you need point to point or sometimes they call peer to peer okay from one point to another point okay so point is a machine like from source to destination so that is point to point that's why they call that machine endpoint so if in some distributed system they call the system peer to peer system okay peer to peer system or in short P2P so peer to peer system peer endpoint is also a machine okay but when we learn about the communication chapter we know that in order for machine to communicate each other they need to know the IP address and the port number without knowing IP address and port number we can't communicate with that machine, okay? Because there are a lot of machine in the internet or in our network, okay? អញ្ចឹង socket បើសិនជាយើងភ្លេចមេរៀនហើយម្លឹកឡើងវិញ socket គឺជា endpoint ហើយ endpoint ហ្នឹងគឺម៉ាស៊ីនគឺ computer ឬមួយក៏មិនបាច់ចាំតែ computer គឺជាម៉ាស៊ីនស្អីមួយហ្នឹងទៅហើយតទៅពេលអាម៉ាស៊ីនហ្នឹងអីគេទៀតបើសិនជាយើងមើលអា behind the scene វាតាមពិតទៅពេលដែលគេចង់និយាយ socket ឬមួយក៏ endpoint ហ្នឹងគឺគេចង់សំដៅទៅលើ IP address ហើយនឹង port ពីព្រោះនៅពេលដែលយើងចង់ communicate ជាមួយម៉ាស៊ីនណាមួយតើតែយើងស្គាល់ IP របស់វាហើយនឹង port របស់វាអូខេស្គាល់ IP គ្រាន់តែដឹងថាម៉ាស៊ីនមួយណាតទៅពេលយើងស្គាល់ port ទៀតបានដឹងថា software មួយណាតនេះវាមាន hardware ហើយនឹង software អញ្ចឹងពេលដែលយើងដឹង IP ហើយដឹង port ប៉ុណ្ណឹងគឺយើងទៅរកវាឃើញហើយតោះណា so now you memorize back about what is socket. So socket is an endpoint is a combination between the IP address and the port number. So what are some state of the socket? So when we create a socket can live and die. So between the live and die, the life cycle of the socket, they have some state. So do you remember some state of the socket? អញ្ចឹង socket ធម្មតាពេលដែលវាយើងបង្កើត socket វាមានកើតមកហើយវាងាប់ទៅវិញក៏តែចន្លោះអាការកើតហើយនឹងងាប់ទៅវិញនេះគេហៅ life cycle របស់ socket ហ្នឹងវាមាន state បានន័យថាវាមានស្ថានភាព status របស់វាមួយចំនួនមានណាគេនៅចាំថាអា state ហ្នឹងមានអីខ្លះ What are the state of the socket? It is just a theory, okay? In practice, it depends on the operating system, the name of the state. But it is similar. Like what kind of state do you remember? មានណាគេចាំថា socket មាន state អីខ្លះ ភ្លេចអស់ហើយ ភ្លេចអស់ហើយបើកមើលមេរៀននោះឃើញ So here is the state of the socket. Okay, status នោះវាស្រៀងតែគ្នាឯតនេះ state នេះ ភ្លេចអើយសង្ស័យអត់មានមើលមេរៀនទេមើលទៅ Okay, so socket has a lot of state. So we have a listen, sing, send. It is all the message of the communication between two sockets. Okay, so one client machine create a socket. The server machine also create a socket, and then those sockets have some state. So like listen, sing, send. Sing is a synchronization. So normally those are the message sending from client and server, and after they send that message, they become that state. Okay. Like when the socket create, the server create. When it is create, it bind with something. It has a listening state. So it is listening to incoming request. Okay. So that is called listening state. For example, I run the software one application server. So now today, maybe we can learn about a little bit about zero MQ. Okay, for example, like now I have my server here. So this is my server code, the pop heartbeat and pop net. So for example, like when I run the pop net, this one, it means that now my server is in the listening state. That is called a socket state. Okay, so socket is an IP address and a port number. So if you see the IP address and the port number of this server, what are the port number? We can see the code. Distributed system, zero heartbeat, pop cat, pop net. Okay, so what are the IP of this one? Okay, so this is localhost and then the port 5000. Okay, so that is a socket. And now when I start the machine, start the code, it is in the listening state. So that is called socket state. Understand? Where is the socket state? Is here. Okay, so listening state. អញ្ចឹងយល់អា socket status ឬមួយក៏ state ហ្នឹងមានន័យថាម៉េចមានធម្មតាពេលដែលយើងឲ្យអាម៉ាស៊ីនហ្នឹងវាចាំតំណតំណងគ្នាហ្នឹងគឺវាត្រូវចាប់ផ្ដើមពីកើតរហូតដល់ងាប់ទៅវិញអញ្ចឹងកើតឡើងភ្លាមគឺវាចាប់ផ្ដើមបើសិនជា server គឺវា listen អញ្ចឹងទៅតទៅពេលអា client គឺវា send អា message ហ្នឹងទៅ server ហើយបានវារងចាំចម្លើយពី server មកហើយ server ពេលដែល server ឆ្លើយហ្នឹងឲ្យតែឆ្លើយហ្នឹងគេហៅ acknowledgement ហើយអូខេអញ្ចឹងពេលដែលយើងរៀន network ហ្នឹងយើងដឹង acknowledgement ហ្នឹងបានតែឆ្លើយតបហើយតទៅពេល establish ហ្នឹងបានន័យថាវា establish the connection ហើយតោះណា Chẳng cái lại nè bạn này tha server nó cứ việc bạn listen hay tao phải miền connection máu việc accept the connection, okay? So that these are all the socket state, but normally the name is the lecture said, it is depend on the operating system. For example, like some operating system, they call the message that send to from client to server sync send, but some other operating system they call something else. Okay, so only the word is different, but the idea is the same. When there are two sockets created, they have some state. So for example, like now the server is bind with the local host and then port 5000, and then now it is in the listening state. Okay, so if I have client, so I have some code about the client. For example, here, if I have client and now my client want to connect to, so let's see the code. Okay, so now my client want to connect to localhost port 5000. Okay, so if I run the client code, and now my client start sending the message to the server, and when the server accept the connection, it will establish the connection. Okay, now it connect to each other, and then the server and the client can send the message to each other. You can see that the server is sending the message to the client all the time in every 1 second. Okay, so that is called socket state. So when it has connection, the server accept it, it can send data to each other. So this we can call all the state. Okay, but in theory we call like this because behind the scene there are some message are sending, because all of the message is handled by the technology. For example, like if we use some kind of technology like for Linux socket or some, for example, like this code, I use the serial MQ messaging protocol, so that are the high level one, but behind the scene they have the certain state here. Okay, ចឹងមានឆ្ងល់អត់មាននៅឆ្ងល់អត់ថាស្អីគេជា socket state ចឹងបើសិនជាបញ្យល់ជាខ្មែរមានន័យថាម៉េចអា socket ហ្នឹងពេលដែលវាកើតមកវាត្រូវតំណែងគ្នាហើយនៅពេលដែលវាតំណែងគ្នាពេលដែលវាបដូរពីបានន័យថាពេលដែលវាធ្វើ action អីមួយគឺវាផ្លាស់ប្ដូរអា state វាមួយហើយដោយថាដំបូងវាកើតបន្តមកទៀតវារងចាំស្ដាប់បន្តមកទៀតវា receive connection បន្តមកទៀតវា connection ហ្នឹងទៅបន្តមកទៀតវាអាចនិយាយគ្នាបានបន្តមកទៀតវាបញ្ចប់ទៅវិញហ្នឹងទៅតោះណាហើយអា message ទាំងអស់ហ្នឹងភាគច្រើនគឺវារៀង low level តិចមានន័យថាបើសិនយើងទៅសេ C program ឬមួយក៏ assembly program បានយើងឃើញអា message ហ្នឹងមែនតែនតែតទៅពេលយើងទៅសេអា high level program ដូចថាយើងប្រើអា Linux socket ឬមួយក៏យើងប្រើ 0MQ ឬមួយក៏យើងប្រើអីហ្នឹងអា message ហ្នឹងយើងឡើងឃើញអស់ហើយយើងគ្រាន់តែឃើញកូដមួយចំនួនហ្នឹងគឺយើងគ្រាន់តែឃើញបង្កើតមកវា listen ហើយវានិយាយគ្នាបដ ாய் តោះនេះយើងអត់ឃើញអាវា send message ទៅដើម្បីភ្ជាប់ដើម្បីស្អីយើងអត់សូវឃើញហ្មងទេតែ behind the scene គឺវាមានអាហ្នឹងយល់ understand yes no okay not not sure. Okay, so next question. So who can tell me what is the difference between RPC, REST, and gRPC? For example, like when do we use REST? When do we use gRPC? Or when do we use gRPC? Or what is the difference between RPC and gRPC? So a simple question like when do we use RESTful for communication? Là cái tiếtឈ្មោះលយ Dara តើពេលណាយើងប្រើអា communication បែប RESTful ដូចធម្មតាពេលយើងបង្កើត website ភាគច្រើនយើងបង្កើត API យើងហៅ RESTful API យើងសួរថាពេលណាយើងប្រើអា RESTful ហ្នឹងនៅក្នុងការកលៈទេសៈបែបណាឬមួយក៏យើងបង្កើត system បែបណាដែលយើងប្រើអា REST ហ្នឹង Dara លឺអត់
លឺគ្រូ
អូខេតោះឆ្លើយចេញអត់
ខ្ញុំអត់ឆ្លើយអត់ចេញផងគ្រូ
ចឹងមកន័យថារៀនមិនរៀនហើយភ្លេចអស់ហើយចឹង Okay, sorry. When do we use REST? Because otherwise we know a lot of technology, but we don't know how to use it, when to use it. So like, when do we use REST? We know that when we build a website, we use REST. Like, so what?
យើងប្រើ REST នៅពេលដែលមានតែ server ហើយនឹង client reply គ្នាទៅវិញទៅមក
មួយណាក៏សារ client reply server ដែរ
I don't know ជាច្រើន
អូខេ20ហ្នឹងណាតិចទៀតហៅស្រីឆ្លើយទៅត្រូវវិញផអត់សូវចេះវិញតោះស្រីម៉ៅតើពេលណាយើងប្រើ rest តែរៀនហើយអត់ចេះទៅមុខទៀតក៏នៅអត់ចេះដែរអញ្ចឹងចេះមួយសិនចាំទៅមុខទៀតតែមេរៀនថ្ងៃហ្នឹងក៏ស្រួលដែរ clock អូខេស្រីម៉ៅ when do we use rest what is the benefit of using rest communication what ស្រីម៉ៅបាទ so if I open the lesson again maybe you can recognize and then can answer it okay so here is a rest so when you see this one when do we use rest មានអ្នកគេឆ្លើយចេញអត់លើពេលបើកអា page នេះមកអក្សរនៅលើនឹងច្បាស់ចេះតោះណាគេឆ្លើយបាននេះអក្សរនៅលើនឹងច្បាស់ចេះនេះ when do we use rest តារាឯងមិញឆ្លើយចេញអត់នេះឃើញអក្សរនៅលើហ្នឹងអី Hello តារាឃើញអក្សរនៅលើហ្នឹងអត់
Yes, sir.
ហ្នឹងហើយ when do we use rest
Alright, review for growth.
yes the rest is good for crude operation តើណាបានន័យថាពេលណាដែលយើងប្រើ rest when we build a website we need to create a table and then we need to insert some data to the table to the database we need to update we need to delete so those kind of simple system rest is a very good for develop if you use a RPC or gRPC or something else it's very difficult okay but when you use rest it's very simple and then when you want to call those operations you just call an endpoint here just like here endpoint is a URL okay this URL is also an IP address but it has some specific subdomain name like domain API and resource something like that and the port is 80 so when you want to create this kind of that kind of application REST is very good and very easy to use okay not complicated like RPC អញ្ចឹង REST គឺប្រើពេលណាប្រើពេលដែលយើងបង្កើតអា system បែបលក្ខណៈបង្កើត data read data delete data អីចឹងទៅ update data ទៅជាពិសេសគឺអា website ហ្នឹងហើយឧទាហរណ៍ថាដូចបង្កើតអីគេ student បង្កើត e-commerce បង្កើត product បង្កើតអីហ្នឹងគឺអាហ្នឹងប្រើ REST មហាស្រួលហើយតើណា understand យល់នៅ REST គឺប្រើពេលដែល system របស់យើងបែប CRUD operation okay REST is easy for CRUD operation so how about RPC what are the benefit of using RPC remote procedure call so like this program this kind of program is a program of RPC like this one when you see this one it is an RPC like an similar to RPC okay like this one or maybe the RPC code so this is RPC okay so this we use RPC so now like what are the system that is useful for using RPC communication មានអ្នកគេដឹងព្រោះមិញយើងដឹងថា REST គឺប្រើសម្រាប់ easy for CRUD operation ហើយឥឡូវ RPC មិនវិញតោះសំណួរមួយហ្នឹងសំណួរចុងក្រោយរួចទៅយើងតមេរៀនយើងទៀតសុងហេង when do we use RPC what kind of application or system that is the RPC is useful. Hello. Tông Hiền nữa. Về hiện dễ understand tao rồi số ắt trẻ đu theo ta ngay trong phần lon tới đặt sầm đồ chân màu tới là trên tới mình lẹ lon ấy khó khổ tiếc nó khổ bền sợ trẻ tao xong hình bên nắp ở OPC ở nơi bởi dương ắt chết lôi thà ắt chết mà mắt các bạn này xua khổ đồ nẹp xe đào về scat chân chứ ở đằng chết mình chết này sống hên xong phải ngay khỏi tòa hậu ba camera mà bật camera chắc là đằng nơi một computer rồi mới có ngặt chân xong hên Panet when do we use RPC I think maybe next week we should do one quiz or exam so that we will go back to look at the lecture. Panet nớt Panet từ Panet.
Yes,
ហ្នឹងហើយ RPC ប្រើពេលណាកម្មវិធីប្រភេទអីដែលយើងប្រើcommunication បែប RPC នេះដូចខ្ញុំធ្វើយើងមើលហ្នឹង RPC នេះ
អាហ្នឹងវា request ទៅ server
ហ្នឹងហើយ request ទៅ server website ក៏វា request ទៅ server ដែរនេះឧទាហរណ៍យើងដូចយើងបើក browser មួយ www.google.com ហ្នឹងអាហ្នឹងក៏វា request ទៅ server ដែរហើយតទៅពេល Google ផ្ញើមកវិញផ្ញើ page នេះមួយមកតទៅពេលមួយនេះក៏វា request ទៅ server នេះពេលវា request ទៅ hello ទៅ server ឆ្លើយ hello អញ្ចឹងទៅហើយវាចេញវាអត់ server អត់ផ្ញើអីមកវិញដោយសារនេះយើងទៅសេឲ្យតែ server បង្ហាញអញ្ចឹងពេលដែលយើងទៅសេទៅវា server ទទួលបានហ្នឹងនេះវា request ទៅ server ដែរតោះណាហើយជាមួយខ្ញុំឲ្យមើលអា zero MQ មិញក៏វា request ទៅ server ដែរឧទាហរណ៍ថានេះ server កំពុង run server កំពុង run ខ្ញុំបើក client មួយទៀតអា client មួយហ្នឹងក៏វា request ទៅ server ដូចគ្នាស្អីក៏វា request ទៅ server ដែរតទៅពេលអាមួយនេះក៏វា request ទៅ server ដែរនេះហើយតទៅពេលឲ្យ server send message មកឲ្យវាវិញនេះឧទាហរណ៍ថាប្រហែលប្រហែលជា30ឬមួយក៏3វិនាទី server send message ឲ្យវាម្ដងអញ្ចឹងអាហ្នឹងក៏វា request ទៅ server ហើយ server send ស្អីមកឲ្យវាវិញដែរហើយអានេះគឺ RPC ដែរអញ្ចឹងសួរថាតើ RPC យើងប្រើពេលណាតោះអ្នកផ្សេងមានអ្នកគេចេះអត់ក្នុងចំណោមគ្នាយើងនេះ9 10នាក់នេះពេលណាប្រើ RPC កុំឲ្យថាចេះហើយខ្ញុំអត់បានហៅ Who know like when do we use RPC
ចាអាហ្នឹងដូចយើងប្រើសម្រាប់ communication ដូច access ទៅ website មួយចឹង
ឧទាហរណ៍ថាឥឡូវអា web នេះក៏ access ទៅ website ដែរតែវាជាលក្ខណៈ REST ហ្នឹងនេះឧទាហរណ៍ដូចខ្ញុំវាយ www.google អញ្ចឹងអាហ្នឹងក៏យើង access ទៅ website ដែរកុំតែអាហ្នឹងបែប RESTful API វាមិនមែនជា RPC Okay, so let me answer and then we will continue our lesson and don't forget to go back to read the lesson and watch the video again, okay? So normally RPC is good for action for action or chat. For example, like here in the chat application, it is not a CRUD operation. So when chat application like a client and server want to communicate by sending message to each other and like continuously, that type of application socket is very useful, okay? And sometimes like we want the computer to do certain kind of action, so that kind of thing RPC is very good. Okay. ចឹងអាភាពខុសគ្នានៃ RPC ហើយនិង REST ហ្នឹងគឺភាគច្រើនបើសិនជាយើង build web application អា REST ហ្នឹងវាស្រួលក៏តែបើសិនជា build អា application បែបលក្ខណៈថា event ឬមួយក៏ស្អីដែលជាលក្ខណៈ action អាហ្នឹងគឺអាពួក RPC វាល្អជាងវិញអូខេចឹងអាហ្នឹងយើងចាំបន្តទៅទៀតទៅ Okay, so now I will show you the last one, and then before we go to chapter 3. So the last one is ZeroMQ. So ZeroMQ is not it's not the technology for communication. It is a messaging protocol. Okay, so inside ZeroMQ they use RPC. Okay, so or sometimes they can use also REST because ZeroMQ is a kind of framework. And then when we use a ZeroMQ technology, we can use RPC, we can use REST, we can use gRPC, something like that. So if you look at the code here, so when I open the code for you, for example, like this one we don't use ZeroMQ, okay? So this one we only use a normal library. So here you can see that we only use the network library in Node.js. So it is only to create a server and use for communication with each other. So when we don't use like a messaging framework, for example, like if I use a node pop, I run this server net, and then I run the client node client net. Okay. So now you can see that this application is only to know that the server is running or not. Okay, so the client request to the server. If the server is running, server will send some information back, for example, like timestamp or that to the client. So if the client receive this one, it means that server is still running. Okay, but when the server die, Control C. So now when the server die, the client also die immediately. Okay, so that we don't use the messaging protocol. អញ្ចឹងអានេះមានន័យថាម៉េចមានន័យថាលំហាត់មួយនេះគ្រាន់តែចង់ដឹងថាតើ server ពេលដែលយើងចង់ connect ទៅ server អា server ហ្នឹងវា on អត់ឬមួយក៏វានៅលាវបានន័យថាវាអត់ងាប់វានៅរស់អញ្ចឹងពេលដែល client send ទៅ server ទៅ server ផ្ញើ information មកធម្មតាហ្នឹងអាហ្នឹងធម្មតាគេឲ្យ heartbeat ដូចចង្វាក់បេះដូងអញ្ចឹងទឹកអញ្ចឹងហើយមកទឹកហ្នឹងគឺវាគ្រាន់តែផ្ញើវាគ្រាន់តែផ្ញើប្រសេ ID ឬមួយក៏ថ្ងៃខែទៅអញ្ចឹងឲ្យតែពេលវាផ្ញើប៉ុណ្ណាមកយើងដឹង client ដឹងថា server ហ្នឹងវានៅរស់ហើយតោះណាក៏តែពេលដែល server ងាប់បាត់គឺ client ហ្នឹងក៏ងាប់ដូចគ្នាដែរដោយសារអីដោយសារតែយើងអត់បានប្រើ messaging protocol. Understand? I explain in English again. So in this case, in this application, the client would like to connect to the server and test if the server is running or not. Okay, just like ping in the networking. So when we ping to the server, if the server running, the server will send a very small amount of message back, in order to not to consume a lot of bandwidth. So that kind of message we call a heartbeat message. Heartbeat, our heart, like our heart, okay? Tick tock, something like that. And then each heartbeat, it only send a very little information like the ID of the server or the date, today, what time, what date, something like that. So if the client receive those information, it means that the server is still running, okay? But if we don't use like a messaging protocol like ZeroMQ or RabbitMQ, there are a lot of technology. If we don't use those kind of framework, when the server die, the client also die, okay? So let's see the second example in order to compare about the messaging protocol. So now I have one server, and for example, I have two clients. Okay, I have two clients here. CD, distributed system, ZeroMQ, heartbeat, sub. Okay, so now I run the server by using ZeroMQ framework. So when we can see the code of this one. So the code, you can see that the system requires ZeroMQ library. So it is a messaging protocol. Okay, so the server is listening to port 8001 and localhost. Okay, so when the server is running, and then now the client is connected to the server. So the first client connected to the server, now it received the heartbeat from the server, like every 3 seconds or 10 seconds, something like that. Okay, and when the second client also connect to the server, it also received the heartbeat from the server. You see that this one received the message at the same time, because we're using a local host, so it's almost at the same time. So now you can see that when we use a messaging protocol, The good thing is when the server die, Control C. So now the server die, but you can see that client still waiting because client didn't receive the message back. Why? Because server already died. Okay. So when server already died, client know that okay, now I didn't receive heartbeat or information from the server. It means the server already died, but the client is not died. Client still waiting for the connection. Okay. So when the server is coming back to the connection, the client still connecting to the server and they know that the server is leaving, so it will continue to receive the heartbeat from the server again. Okay, so this kind of technology we call messaging protocol or messaging framework like 0MQ or RabbitMQ. It ensures that the communication is on all the time. So if the server is leaving, we know the server is leaving. If the server is die, the client stop receiving information from the server, but client still waiting for the server to come back to life. Okay, so the application client application is still running. អញ្ចឹងកន្លែងនេះខ្ញុំចង់បញ្យល់យើងអំពីចំណុចចុងបញ្ចប់របស់មេរៀនរបស់យើងអា 0MQ នេះ 0MQ ហ្នឹងវាមិនមែនជា communication protocol ដែល RPC REST ឬមួយក៏ GRPC នេះទេវាគឺជា framework មួយដែលគេឲ្យឈ្មោះថា messaging framework ពេលយើងរៀន distributed system ម៉ោងទី1ហ្នឹងវាមិនចែកចេញជា3 load balancing node ហើយនឹងmessaging frame protocol នៅខាងក្រោយគេហ្នឹងអញ្ចឹងការពីមុនហ្នឹងគឺយើងប្រើ democracy JS តទៅពេល0MQ ហ្នឹងក៏វាជា messaging protocol ដែរតោះណាបើសិនជាយើងអត់ប្រើវាទេពេលដែល server ងាប់client ហ្នឹងងាប់ដែរក៏តែបើសិនជាយើងប្រើពពួក software ឬមួយក៏ technology បែបmessaging protocol ហ្នឹងពេលដែល server រស់client ហ្នឹងវារស់វានៅដឹងថា server ហ្នឹងរស់ដោយសារ server ហ្នឹងផ្ញើ message មកដូចជាចង្វាក់បេះដូងអញ្ចឹងតោះណាតែតទៅពេល server ហ្នឹងងាប់បាត់អញ្ចឹងទៅ client ហ្នឹងអត់ងាប់ទេគ្រាន់តែ client ហ្នឹងវារងចាំហើយវាអត់បានទទួល message ទេដោយសារ server ងាប់បាត់ហើយតែពេលដែល server រស់ឡើងវិញគឺវាទទួល message តទៀតតោះណាអញ្ចឹងការតំណាក់តំណងបែបហ្នឹងគឺយើងហៅថាការតំណាក់តំណងដោយប្រើ messaging protocol ហើយភាគច្រើនពួក distributed system គឺគេចូលចិត្តប្រើ technology អញ្ចឹងតោះណាយល់ទេ clear like what is the difference by using a messaging protocol and without using messaging protocol? Okay, so in distributed system we need some kind of messaging protocol like 0MQ or RabbitMQ, something like that, so that when the server is die, the client is still running and waiting for the server to come back. Okay, but without using those kind of messaging protocol, if the server die, server application crash, the client application also crash. Okay, so we use a messaging protocol in the distributed system. So this kind of system, we call it a distributed system. You see that the client is still waiting. So when the server is coming back to life, the client will receive the heartbeat from the server and they know that the server is coming back. Okay. So if we have two servers, if one server die, another server will still send a message to the client and the client still receive the message. Okay. And this simple information, we call it a heartbeat information. So in the future, you will know the importance of heartbeat message. Okay, so the heartbeat message is only to ensure that another computer is still living. Okay, that's why we call it heartbeat. So when a human heart is still beating, we survive. But when the human heart stop beating, we die. So the same idea as a client and server who want to know that which machine is die or living. Vô nữa, vô. Client by សិស្សថ្ងៃហ្នឹងអត់ជ្រាបចឹងតោះយល់អត់យល់អ្វីដែលខ្ញុំចង់និយាយអត់ចឹង 0MQ គឺជា messaging protocol ឬមួយក៏ framework មួយដែលគេយកមកប្រើនេះគេហៅ messaging protocol ដែលគេយកមកប្រើដើម្បីរឿងហ្នឹងបានន័យថាទោះបីជា server ងាប់ក៏ client ហ្នឹងវាអត់ងាប់ដែរតើណា and there are a lot of similar messaging protocol, for example like active MQ or RabbitMQ. So those are the technology that used for communication in a distributed system. Okay, distributed system. So when there are a lot of computer, a lot of server, a lot of client, we use those kind of messaging protocol so that when one computer die, another computer or application is still running and waiting. Okay, and this kind of application we call a public subscribe application. So that's why when you go to see the code, pop heartbeat. So when you go to see the code, you can see that now 0MQ is using a socket, which is a public type. So publish mean I publish something. So like server want to publish a heartbeat. Okay. So if you see the client code, you will see that the client is used to subscribe. Gedit sub heartbeat. Okay. That's why I call the file name sub. So you can see here 0MQ using a socket which is subscribe type. Okay. So in 0MQ there are a lot of socket type. So you can see the video that I sent in here, like which one? Or maybe in the slide. I have mentioned in here. So like this information, okay? The video on YouTube. So when you go there, you will see that there are a lot of type socket that we can use. And like in this special case is a public subscribe communication. ចឹងអា socket ហ្នឹងគឺវាមានច្រើនប្រភេទទៀតមិនយើងនិយាយរឿង status របស់ socket ណាក៏តែ socket ហ្នឹងវាមានច្រើនប្រភេទទៀតអញ្ចឹងវាមានអាប្រភេទ request response ដោយ website អញ្ចឹងតទៅពេលអាលក្ខណៈបែបនេះគេហៅ publish subscribe មានន័យថា client ហ្នឹង subscribe ចាំ server មួយអញ្ចឹងបើ server ហ្នឹងរស់គឺ client ហ្នឹងទទួលបានបើសិនជា server ហ្នឹងងាប់ client ហ្នឹងអត់ទទួលបានអូខេដូចព័ត៌មានអញ្ចឹងមានន័យថា client subscribe ទៅកាន់ mailing list ឬមួយក៏អីមួយហ្នឹងទៅអញ្ចឹងបើមានព័ត៌មានមកអាព័ត៌មានហ្នឹងគឺផ្ញើមកឲ្យ client ហើយតែបើសិនជាអត់មានព័ត៌មានទេព័ត៌មានហ្នឹងវាអត់មានឲ្យ client នៅចាំអញ្ចឹងទៅតែឲ្យតែមានព័ត៌មានថ្មីមកទៀតអា server ហ្នឹងវាផ្ញើមកឲ្យ client ហើយដោយសារ client វានៅរងចាំរហូតតនេះអញ្ចឹងអាការទំនាក់ទំនងបែបហ្នឹងយើងហៅថា public subscribe communication. Okay. So in the website we have request response communication. Okay. That's why the HTTP you have request header and response header. But in the some communication we can have a publish and subscribe communication. Okay. So publish subscribe means the server is publish something. For example, like publish news, and then client is subscribed to that news. Okay. Client subscribe to that news. So if there is no new, client is still waiting because a client is still waiting for that new. But if the server has some new, server will broadcast those new to the client. Okay. So this kind of communication we call it a publish subscribe communication. ចឹងពេលដែលយើងទៅ say app ច្រើនពេលខ្លះយើងនឹងជួបអាពាក្យចឹងហើយបានន័យថាបើយើងបង្កើត website វាមានអាការទំនាក់ទំនងបែប request response ហើយពេលខ្លះគឺវាមានលក្ខណៈបែបគេហៅ publish subscribe ហ្នឹងបានន័យថា server ហ្នឹងគឺវាចាំ publish អីមួយហើយបើយើងចង់បានអាព័ត៌មានពីអា server ហ្នឹងមកយើងតតែ subscribe ទៅអា server មួយហ្នឹងអញ្ចឹងរាល់ពេលដែល server ហ្នឹងមានព័ត៌មានគឺវាផ្ញើមកឲ្យ client ហើយអូខេអញ្ចឹងការទំនាក់ទំនងបែបហ្នឹងយើងហៅវាថា publish subscribe communication វិញអូខេ ចឹងមេរៀន communication គឺចាប់ប៉ុណ្្នឹងឯងតែគ្រាន់តែចង់ឲ្យយើងដឹងអំពីរបៀប communication ហ្នឹងវាមានច្រើន technology ចឹងហើយវាមានច្រើនប្រភេទចឹងតោះណាវាមិនមែនតែរឿងបង្កើត website ដូចយើងរៀនរាល់ថ្ងៃហ្នឹងវាមានតែមួយប្រភេទអា request response ហ្នឹងឯង Understand? So in chapter 2 you learn several communication technology and you also learn like two type of communication like request response communication and public subscribe communication, and you need time to learn more in order to know it deeply. Okay, so I think we could finish our chapter 2 now. If you don't have any question, and don't forget to go back and watch the video, and then maybe watch some more video on YouTube to get to know more of those kind of technology. Okay. Otherwise, 1 week later or 2 weeks later, you forget all. Okay, so now let's go to chapter 3, and maybe I think maybe we learn chapter 4 a little bit, and then we do some quiz because otherwise I don't know how much you understand about the lesson. Okay, so today we will learn about the clock and the timestamp. Okay. Let's start chapter 3. So forget about communication or PC, what else. So now let's focus on clock and timestamp. So here are the agenda of the topic today. So these are the general information that everybody know. Okay, but normally people don't really know about this one. Okay, for example, like we know that when the Earth rotates around itself, we call it one day. Okay, so there is a day and night. Today is a Thursday, tomorrow is Friday, and each day has 24 hours, 1 hour has 60 minutes, and 1 minute has 60 seconds. Okay, And then when we focus on the solar calendar, we divided 1 year into 12 months. And then within 1 month, we have like a 28 or 29 or 30 days, something like that. It depends on the moon, okay? But the problem is those information is not, for example, like exact, like 1 day is not exactly 24 hours. 1 year is not exactly 12 months. 1 month is not exactly 30 day or 20 day. It has some kind of problem because everything is not like constant, okay? The speed of the earth, the way the earth rotate around the sun or something like that, it is not constant. Each year it is different all the time. That's why there are always some error, okay? So those error could produce some problem when we want to use something related to time. That's why today we will talk about time, okay? So the first thing that you might not know, before we only have 10 months, okay? That's why when you see the word September, so if you see the word September, so what is the set mean? If you know French, like on the talk at science said, so what is set mean? Mình cái đang set nó ban này thằng mày ạ. Che parang ấy. Set nó parang thằng mày. Hello.
It's 7.
Yeah, 7. So normally before there is no January and February, okay? There is only the first month is March. So if you count from March to September, September is not the 9th of the month, it is the 7th of the month. That's why it has some Latin character embedded inside the word. For example, like set in French is 7, so it is the 7th month. But when we have a 12 month, we call September is the 9th of the month, okay? For example, like December. So December normally, if we count, it is the 12 position of the month. But when you look at the word, for example, like decimal. So what is the decimal mean? Like binary, hexadecimal, decimal. So what is decimal mean? Decimal mean? Mình là cái đằng ấy decimal của pon call man.
Con cột đồng.
Đằng ấy để nhầm đại lịch đọc ạ. Tờ này. So decimal means 10, okay? So before March is the first month, September is the 7th month, and December is the 10th month. So within 1 year, there is only 10 months. There is no 12 months, okay? So if you was born in January or February, it is just the month that add later, okay? So that's why there are a lot of mistake, error when we talking about that, when we talking about time, even in the computer science, okay? So that is something you need to know. So like here's the only a general information, like before we have only 10 months, now we have 12 months, okay? And the other thing is that 1 year is not exactly 365 days. It is more than that. That's why we have one thing called a leap year. So a leap year when there are 366 days, and then we add 1 day to a February. So we have February 29. So everyone who was born in February 29, they have birthday every 4 years. Okay? ចឹងអាចចំណុចមួយទៀតបានន័យថាមួយឆ្នាំវាមិនមែន365ថ្ងៃចំឯងគឺវាលើសជាងហ្នឹងបន្តិចតើណា365ថ្ងៃប្រហែល2 10ម៉ោងឬមួយក៏6ម៉ោងចឹងទៅអញ្ចឹងរាល់4ឆ្នាំម្ដងគេត្រូវបន្ថែមថ្ងៃលើសហ្នឹងចូលទៅក្នុង calendar ចឹងហើយបានវាមានថ្ងៃទី29នេះអញ្ចឹងបើសិនជាណាគេកើតខែថ្ងៃ29ខែ2មានន័យថាម្នាក់ហ្នឹងគឺ4ឆ្នាំបានធ្វើ birthday ម្ដងតើណាព្រោះថ្ងៃ29ហ្នឹងមិនមែនមានរាល់ឆ្នាំទេអូខេ So this we call leap year. So we have an additional day within every 4 years, okay? Because within 1 year there is 365 days and 6 hours, okay? So that's why 6 hours 4 years later they add together within become 24 hours, and then it become 1 day, and then we add to the 29 this February, okay? And the other thing is a leap second. Maybe a lot of everybody know leap year, but not so many people know about the leap second, okay? So leap second is the second which is not correct, and then they adjust it during June 30 or December 31 to make it exactly the same time, okay? So we will see it later in our chapter. So remember that there is also a leap second which is add or reduce during June 30 and December 31, okay? ចឹងរឿងស្អីគេឆ្នាំប្រគ្រប់ឬមួយក៏ឆ្នាំអីហ្នឹងយើងភាគច្រើនយើងដឹងណាបាទន័យថាគេថែមដោយសារមួយឆ្នាំវាលើស6ម៉ោងអញ្ចឹង4ឆ្នាំយក6ម៉ោងបូកបញ្ចូលគ្នាទៅវាបានមួយថ្ងៃគេយកទៅថែមនៅខែ2តទៅពេល leap second នេះក៏ដូចគ្នាដែរវាមានsecond ខ្លះដែលវាលើសហើយខ្វះអញ្ចឹងទៅអញ្ចឹងគេធ្វើការ adjust វានៅថ្ងៃខែ6ថ្ងៃ30ហើយនឹងខែ12ថ្ងៃ31អូខេអាហ្នឹងគេហៅ leap second តិចទៀតយើងឃើញ leap second ហ្នឹង Okay, so in this chapter, like how do people measure 1 second? Okay, for example, like how do people measure exactly one second? So the scientists always try to find some technology or some material like mechanical, electrical, something like that, in order to have those kind of technology that measure exactly 1 second, like tick 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 tick, something like that. Okay, but it is hardly find those kind of material physically or electronically, something like that. So that's why there is always some kind of error inside the second, even a second, not that or hour. So in 1955, people create an atomic clock. So what is atomic clock? Atomic clock is a clock by using one atom, and that atom is called is choosing from cesium-133 material. So these are the physical material like stone or wood or something like that. So they choose this atom, and also the second is count depend on the vibration or oscillation of that electron inside that atom. Okay, so by exposing it to the electromagnetic field, it has some certain kind of vibration, and then we count it as 1 second. So when this atom vibrate like this certain amount of number, we call it 1 second. Okay, so we create a clock by using this kind of atom. Okay, and the other clock is called a quad clock. So quad clock is another type of clock by using a quad. So quad is also another material. Okay, so that's why in order to create a clock during the past to the present, people try to find something that is very constant, and then the characteristic or the property of creating a clock is the vibration or the oscillation. So if it is oscillation in the constant time, it is easy to create a clock. Okay, but remember that every kind of physical or atom or something like that, there is always some error, like faster they vibrate faster or slower. So that's why even 1 second is not really exactly 1 second. Okay, អញ្ចឹងpage មួយនេះគឺចង់និយាយអំពីប្រវត្តិនៃការបង្កើតម៉ោងយើងដឹងថាកាលពីឆ្នាំ55ហ្នឹងគេបង្កើតម៉ោងមួយយ៉ាងគេឲ្យឈ្មោះថា atomic clock. atomic clock ហ្នឹងគឺគេប្រើប្រាស់ធាតុគីមីមួយយ៉ាងដូចធម្មតាធាតុគីមីវាតាក់ទងជាមួយនឹងរឿងphysics ដូចថ្មឈើឬមួយក៏ដែកឬមួយក៏ស្អីៗអញ្ចឹងគេយកធាតុមួយឈ្មោះថា cesium ហ្នឹងហើយរួចទៅគេយកដែន electromagnetic field ហ្នឹងបាញ់ទៅលើអាតូមមួយហ្នឹងដើម្បីឲ្យវាមាន vibration ហើយរួចទៅគេរាប់vibration របស់វាហ្នឹងបានន័យថាបើសិនជា vibration របស់វា vibrate បានចំនួនប៉ុណ្ណេះគេចាត់ទុកថាវាជា1វិនាទីតោះណាហើយវា vibrate រហូតអាហ្នឹងបានន័យថានៅពេលដែលយើងដាក់ magnetic field ទៅលើអាតូមមួយហ្នឹងទៅវា vibrate រហូតអញ្ចឹងនៅពេលដែលធម្មតាវា vibrate លឿនអញ្ចឹងហើយបានឃើញអានេះរាប់លានហ្នឹងអញ្ចឹងពេលដែលវា vibrate ប៉ុណ្ណឹងដងគេសន្មតថាវាជា1វិនាទីហើយគេយកអាមួយហ្នឹងយកទៅបង្កើតជាម៉ោងជាអីហ្នឹងទៅដាក់លើនាฬิកាដាក់លើកុំព្យូទ័រដាក់លើអីហ្នឹងទៅតោះណាតទៅពេលរហូតក្រោយមកទៀតគឺគេប្រើអាធាតុមួយទៀតគេឲ្យឈ្មោះថា quark ហ្នឹងអញ្ចឹងបានគេហៅថា quark clock ម្ដងតោះណាតែអាមួយនេះវា accurate ជាងអាមួយនេះ okay. So remember, in order to create a clock, we need something vibrate. In order for something vibrate, people use different kind of material and technology. The first material is cesium, and then by using electromagnetic field exposed to it, and they count the vibration of it, they consider it as 1 second. And these are the most accurate clock in the planet. Okay, and in the computer we don't use this one because it is expensive. So they use another kind of material called quad. So quad is the same thing. They also count the vibration of the quad and then use to create a computer clock, something like that. So it is less accurate than atomic clock. So that's why people is count on atomic clock rather than the quad clock. Okay. So you can see that the clock is depend on some kind of physical material, and that kind of material has some error. That's why we have some problem if we want to talk about the clock. So there's one thing called clock drift. So clock drift means clock error gradually increase For example, like now it's 1 second, and then the next second is 2 seconds, but it move faster, so it become like 2 seconds and 2.1 seconds, something like that. Okay, so if the clock is like a vibration is very faster and faster, something like that, or slower and slower, that is called a clock drift. So it is an error. Okay, so another thing is called clock skew. So skew, okay, clock skew. So what is clock skew mean? The difference between two clock at a point of time. So for example, like you have two clock, you using the same technology, but one clock is located in one place and another clock is located in another place. And then when you compare the clock, it has different. So the difference between those two clock, we call it clock skew. Okay, so for example, like today I buy one clock and you buy one clock, and I stay in Cambodia and you move to United States, and then we start the clock at the same time. And 1 month later, when you come back from United States and to Cambodia, and then we compare those two clocks together, it is not the same time, because the vibration of the material inside the clock is different. It has some error. So when we compare those clock, it has a it different in some millisecond. Okay, like 100 millisecond or 500 millisecond, something like that. So those different, we call it clock skew. តោះយល់ទេយល់តាក់ទងរឿងម៉ោងហ្នឹងមានន័យថាទោះបីជាយើងមានម៉ោងដោយប្រើអា material ដូចគ្នាក៏ដោយម៉ោង2ហ្នឹងគឺมันប្រកាសថាដូចគ្នាជារៀងរហូតទេដោយសារតែអា speed vibration របស់វាវាមានពេលខ្លះលឿនពេលខ្លះយឺតអញ្ចឹងទោះបីជាយើងមានម៉ោង2ក៏ដោយហើយយើងទិញពេលជាមួយគ្នាយើង set វាពេលជាមួយគ្នាមួយខែក្រោយមកមួយឆ្នាំក្រោយមកយើងយកអាម៉ោងមកប្រៀបធៀបគ្នាគឺវាខុសគ្នាតិចតួចតោះណាវាអាចខុសគ្នាប្រហែល millisecond ឬមួយក៏ second ឬមួយក៏អីយ៉ាងទៅហើយអាភាពខុសគ្នាហ្នឹងយើងឲ្យឈ្មោះថា clock skew ហើយបើវាអាភាព error របស់វាហ្នឹងយើងឲ្យឈ្មោះថា clock drift. Understand these two words, clock drift and clock skew. តោះមុននឹងតទៀតយល់អត់ប៉ុណ្ណឹងព្រោះបើអត់យល់ទេយើងអត់អាចទៅមុខទៀតបានទេ Okay, everyone understand what is clock drift and clock skew, because otherwise you will not understand why there is problem when we use time in a computer. Hello, everyone. Understand? If you understand, say yes. Hello. Okay. So now you know that within that and time there is always some error. Even one second there is also some error. Okay, and then you will start to see there are some problem in the computer. Okay, so because we have those kind of problem, that's why the scientific community in the computer science, they create one thing called NTP. So if you go to your computer, you will see that all the computer is using some kind of called a time server. Okay, we call it network time protocol, NTP. Okay, so normally NTP is using atomic clock, so the clock which is very accurate. So that's why all the client computer need to retrieve the clock from the server computer. When you have the internet connection, you will retrieve the clock from the server. Okay, or some GPS receiver. So what happens if your computer and the server computer has different clock? Have you encountered this kind of problem? So for example, like now, currently it is 8 a.m. And then for example, like if you set your computer or your browser, your computer to 7 a.m. or like today is March 10, and then you set your time to March 7, something like that. And then when you open the internet, what is the problem? You will see some error like this. So what is this kind of error? Your computer clock is set to, for example, like here is September 2021. Make sure that your computer is set to the correct date, time zone in your system setting, and then refresh google.com. So when your browser want to request to a website, but your computer time and then the Google server has different time, you will have some kind of error like this. Okay, why? Because the time of the two computer is very different. Okay, So if you have time, try to reset your time and then try to open the internet. You will see some kind of error like that. អញ្ចឹងបើសិនជាកុំព្យូទ័រវាមានម៉ោងខុសគ្នាហើយពេលដែលយើង communicate គឺវាច្បាស់ជាជប់វានឹងមានបញ្ហា error មួយចំនួនតោះណាអានេះ browser ផង application ក៏ដូចគ្នាដែរបើសិនជា application ណាដែលធ្វើការតាក់ទងជាមួយនឹងម៉ោងហើយតែយើងអត់ធ្វើវាឲ្យស្រួលទេគឺ application ហ្នឹងក៏វា crash ដែរ okay okay so let's talk a little bit more about the time so we know that the client machine and the server machine need to talk to each other in order to retrieve the time okay so here when we have two machine two NTP machine NTP like a network time protocol so when the client requests the time to the server the moment that it requests to the server we call it T1 time 1 so when the request is arriving at the server we call it T2 okay so that is called a request time so it take T2 minus T1 time for the request from client to the server and then server need to wait a little bit so the time for the server need to wait a little bit is from T2 to T3 okay so in T3 when server is on T3 the server will respond the message back to the client okay so client will receive at T4 okay so why do server respond back T1 T2 T3 to the client because the T1 and T4 T2 and T3 within the server and client will not be exactly as you know that when we use some kind of material there is always some kind of different okay so that's why we don't know when our time is T1 here and then a T2 server here we don't know here is T2 in the client or not okay so that's why when the communication that need to count on the time when the client sends something to the server the client need to tell that okay now I sending my request with the time T1 but when the server respond back to client server need to send back T1 the time of the client T2 the time it receive the request T3 the time that it send the request back and then T4 is the time that it arrive okay so in client will know T1 T2 T3 T4 all everything like when do the server receive my request and when do the server start to respond to me okay so in order to calculate the we call a round trip time round trip network delay this is the formula like a T4 minus T1 minus T3 minus T2 so that is we call it a round trip so from client to server and from server to client okay អញ្ចឹងកន្លែងនេះគេចង់និយាយអំពីការទំនាក់ទំនងរវាង client ជាមួយ server តាក់ទងមួយរឿងម៉ោងតើនេះបានន័យថាពេលដែល client send ស្អីមួយទៅ server គឺ client ហ្នឹងត្រូវប្រាប់ថាខ្ញុំ send ម៉ោងប៉ុណ្ណេះ T1 តើដល់ពេលមកដល់ server T2 ក៏តែឧទាហរណ៍ថាឥឡូវ server T2 យើងមិនប្រកាសថា client ឥឡូវគឺ T2 ទេតើនេះវាអាចខុសគ្នាដោយសារតែវាមានអាភាព error ហ្នឹងអញ្ចឹងហើយបានជាហើយរួចទៅ server ក៏ត្រូវការពេលមួយចំនួនដើម្បីឆ្លើយតបមកវិញដែរអញ្ចឹងពេលដែលវាបញ្ចេញ request មក response មកវិញហ្នឹងគឺវាម៉ោងវា T3 ហើយចឹង server នោះត្រូវបញ្ជូនម៉ោងមកវិញទាំងអស់មានន័យថាT1 នេះគឺ client ផ្ញើមកឲ្យ server នោះ server ផ្ញើអាហ្នឹងទៅវិញបន្តមកទៀតT2 នៅពេលដែលវាទទួលបានហើយនឹង T3 ពេលដែលវាឆ្លើយទៅវិញហ្នឹងក៏វាត្រូវផ្ញើទៅវិញដែរតើដល់ពេលវាមកដល់ client ដឹងថាឥឡូវវាមកដល់គឺ T4 ហើយអញ្ចឹងដើម្បី calculate ថាតើមក client ទៅហើយរហូតដល់មកវិញហ្នឹងវាស៊ីរយៈពេលអស់ប្រមាណគឺអានេះគឺជារូបមន្តតើហ្នឹងគេហៅ round trip network delay ហ្នឹងគឺយើងយកT4 ដក T1 ក៏តែយើងយក T3 ដក T2 ទៀតដោយសារពេលនេះគឺយើងអត់រាប់ទេតោះណាអញ្ចឹងយើងយកអានេះដកអានេះដកនឹងអានេះដកនេះទៀតអាហ្នឹងគេហៅថា round trip network delay okay so here are some formula related to time so we have a four time point T1 to T4 and then if you want to calculate the round trip network delay is this formula and then the other formula estimate server time when client receive response so for example like now client receive response at T4 but do you know that the server is also T4 or not we don't know okay because the time in the client machine and the time in the server machine is always different there are some error so that's why we use an estimation okay you see the word estimation here so now client request server respond and now client receive at T4 but we don't know if now server is T4 or T5 or T6 we don't know so in order to calculate that we use T3 so T3 is the time that the server send back plus the round trip divided by 2. Because why? Because we estimate that the request and response taking the same time. Okay, we assume that it is taking the same time. So the time that going for the request is the same time going back to the response. That's why we use the total round trip time divided by 2. Okay, so T3 plus total time divided by 2, and we call it the server time when the client receive the response. So like, for example, like client receive response at T4, but what is the time at the server? Okay, so we estimate that the server might be T3 plus the total time divided by 2. And then there's also a clock skew, which means there's some error. Okay, so the error between the client and the server clock is this formula. So T3 plus this one minus T4. Okay, so we can replace this formula by this one. So this we call it a clock skew, which is the error, like what is the error rate of the time between compare between the client and the server. Understand? So now we have a 3 formula. One is the round trip network delay. The other one is the time that the server, that the client receive the time at the server when client receive the response. Okay, and the other one is the total error of the time compare between the client and the server. ចឹងអាមេរៀននេះវាមានរូបមន្តកណិតតិចបើសិនជាយើងអត់សូវចូលចិត្តកណិតទេយើងប្រហែលរៀងវែងបន្តិចអូខេតែកុំតែព្យាយាមយល់វា ចឹងឥឡូវមានអីអត់យល់តាក់ទងជាមួយនឹងរឿងរូបមន្ត3នេះរូបមន្តទី1គឺតាក់ទងជាមួយនឹង round trip រូបមន្តទី2តាក់ទងជាមួយនឹងម៉ោងនៅលើ server ដែល client ទទួលបាន response បានពេលដែល client ទទួលបាន response នៅម៉ោង T4 ហ្នឹងតើអា server នេះម៉ោងប្រហែលតោះណាអាហ្នឹងគឺអាមួយនេះតទៅពេលអាចុងក្រោយនេះគឺអា error បានន័យថានៅពេលដែល client វាម៉ោងប៉ុណ្ណេះហើយនឹង server ម៉ោងប៉ុណ្ណេះហើយម៉ោង2ហ្នឹងពេលប្រៀបធៀបគ្នាទៅស្រាប់តែវាខុសគ្នាអញ្ចឹងសួរថារូបមន្តមិនដើម្បីកណនាអាភាពខុសគ្នាហ្នឹងគឺរូបមន្តទី3នេះអូខេ understand the three formula round trip formula server time when client receive response and the last one is the error, or maybe we can call it the different time between server and client. Okay, so that are the three formula. យល់ formula 3ហ្នឹងអត់មានអា formula មួយណាអត់ច្បាស់ហ៎ Hello ទាំងអស់គ្នាយល់របៀបកណនារូបមន្ត3ហ្នឹងអត់
for your estimated clock skew
clock skew អូខេ clock skew ហ្នឹងគេចង់និយាយពីអីឥឡូវយើងមើល T3 សួរថា T3 អាណា so T3 is this one okay so T3 plus T3 plus total time divided by 2 so like this one okay so this one is the time of the server when the client receives something okay and then you can see that here is the time of the server and then minus T4 so minus T4 mean why do we minus T4 we want to know that if this time and this time are the same or not okay so maybe I can draw the diagram to explain it's more easy okay so now we have client and server okay okay so now when client send something what are the time here so this is T1 okay so when the request arrive here it is what it is T2 okay so do you think that here client also T2 but when the client when the server is T2 do you think that client is also T2 ចឹងបានន័យថាពេលដែល client send request មកវានៅម៉ោង T1 ណាតើពេលវាមកដល់ server នេះ T2 នេះអញ្ចឹងឥឡូវសំណួរសួរថានៅពេលដែល server T2 តើយើងប្រកាសអត់ថា client វា T2 ដែរHello nè xua mình chui chloi thì mà bạn này thà lấy server thi thu rồi chứ xua thà lấy đó ạ client nó thi thu đại ọt so here is the how the time is moving so the time is moving like this okay so for example like this 0 second and now is 1 second and here is 10 seconds something like that so time is moving downward so for example like here is the time that the client sends something to the server and server receive at this time okay so for example like we can say okay if you don't know t1 t2 let's say 9 o'clock at 9 o'clock client send something okay when it arrive here it is like 9-10 minutes okay normally it is a millisecond or microsecond but let's example like this so that you understand so for example like 9 o'clock client send something it arrive at server at 9-10 minutes okay so now when server is 9 and 10 minutes do you think that client is also 9 and 10 minutes now we're talking about now here hello អត់មានអ្នកឆ្លើយមួយខ្ញុំចឹងអត់មានអ្នកឆ្លើយមួយខ្ញុំចឹងព្រានមកយល់
Yeah, teacher.
ដូចគ្នាអត់
Yeah.
No. Okay, if you say yes, you don't understand. No, why no? Because there is always an error of the clock between the client and the server. Okay, remember that client and server using some kind of material, for example, like quark, okay, or atomic or something like that. Okay, so when the two clock is using some kind of material, that material is having an error. There is always some error between two clock of the two machine. Okay, let's say it is not client server. Let's say machine 1 and machine 2. Okay, so each machine has the same time, but sometimes there is also some error between the two machine. Okay, that's why we call the clock has a clock skew. Okay, why the clock has clock skew? Why the clock has clock skew? Because each material oscillate or vibrate within different vibration within a very small area of vibration, and those area we call it a clock drift. តើហ៊ានហើយមិញណាបានន័យថាម៉ោងធ្វើម៉េចបានដឹងថាម៉ោងមួយនាទីមួយវិនាទីមួយវិនាទីទឹកហ្នឹងគឺគេប្រើ material អីមួយតែ material ហ្នឹងយើងដឹងថាវា vibrate ហ្នឹងវាអត់ constant ទេវាមាន error ទូចដែលយើងសឹងនឹងមើលអត់ឃើញទេប៉ុន្តែវានៅតែ error អញ្ចឹងតោះនេះវានៅតែមានអាភាព error ហ្នឹងអញ្ចឹងអាភាព error ហ្នឹងយើងហៅវាថា clock drift តោះនេះតទៅពេលអាម៉ោងនេះបានន័យថាអាម៉ោងម៉ាស៊ីនមួយនេះហើយនឹងម៉ោងម៉ាស៊ីនមួយនេះបើទោះបីជាវា start ពេលជាមួយគ្នាក៏ដោយឧទាហរណ៍ថាអាមួយនេះវា start ម៉ោង9ដូចគ្នាក៏ដោយតោះនេះតែពេលដែលវាដើរទៅមុខទៀតដើរទៅវាច្បាស់ជាមានអាលឿនហើយនឹងយឺតទេតោះនេះអាលឿន error លឿនយឺតហ្នឹងយើងឲ្យឈ្មោះថា clock drift ហើយអាពេលដែលយើងយកអាពីរហ្នឹងយកមកដកគ្នាមកគេឲ្យឈ្មោះថា clock skew តោះនេះឲ្យយល់អាពីរពាក្យហ្នឹងសិនណានេះមេរៀនយើងមិញនេះនេះ clock drift ហើយនិង clock skew បើយើងអត់យល់ប៉ុណ្្នឹងទេយើងក៏អត់យល់អារូបមន្តមួយនេះដែរតើណាប៉ុណ្្នឹងយល់នៅ understand the clock drift and clock skew why clock drift and clock skew happen because time is not constant. Why time is not constant? Because the way we measure time is using certain kind of technology that those technology has some error. It is not perfect. Okay. If it is perfect, there is no clock. There is no clock drift and clock skew, and then this T2 will equal to this T2. But because there is some error, that's why it produce clock drift and clock skew, and then that's why this when server is T2, we don't know exactly if client is T2 or not. Okay, it may have some error. For example, like if server is 9 and 10 minutes, client may be 9 and 9 minutes, or maybe 9 and 11 minutes. Okay, it may be like this. And then when it is error like this, we call it clock drift. Okay, for example, like now client is 9 and 11 minutes, and then server is 9 and 10 minutes. So the difference is 1 minute. Okay, so that 1 minute we call it a clock skew. យល់អត់យល់ប៉ុណ្ណឹងហ៎ hello យល់អត់អត់យល់ខ្ញុំនិយាយខ្មែរនេះធ្វើម៉េចឲ្យយល់អាពីរពាក្យនេះ clock drift ហើយនិង clock skew តើពេលយើងយល់អាហ្នឹងបានយើងយល់អារូបមន្ត3មិញទៀតតែពិតមេនេះស្រួលក៏តែដោយសារតែយើងដូចថាខ្ជិលកាច់យើងខ្ជិលគិតយើងខ្ជិលប្រើខួរក្បាលរូបមន្តកពិកកពុកហ្នឹងបោកដកហ្នឹងតើឥឡូវយល់នៅយល់ clock drift ហើយ clock skew នៅបើថាអត់យល់អាពីអង់គ្លេសហ្នឹងទៅបកជាខ្មែរមក clock drift មានន័យថាម៉ោងវាមានបញ្ហាម៉ោងវាមាន error តើពេលអា clock skew នោះមានន័យថាម៉េចនៅពេលដែលម៉ោង2អាម៉ោង1ម៉ោងចេះអាម៉ោង1ទៀតម៉ោងចុះហើយអាភាពខុសគ្នាហ្នឹងគេឲ្យឈ្មោះថា clock skew នៅពេលដែលវាអត់ដូចគ្នាហ្នឹងឧទាហរណ៍នេះឥឡូវហ្នឹងទៅមើលម៉ោងនៅលើ server បើសិនយើងមានភ្នែកទៅកលេចមើលទៅឃើញទាំងសងខាងទៅមើលអា server ឃើញម៉ោង 9:10 នាទីតទៅពេលមកមើលអា client 9:11 នាទីអញ្ចឹងវាខុសគ្នា1នាទីនេះអាភាពខុសគ្នាហ្នឹងឯងគេឲ្យឈ្មោះថា clock skew យល់អត់យល់ដល់ពេលបញ្យល់ខ្មែរហើយអត់យល់ទៀតអត់ដឹងថាម៉េចទេ client and server okay so now T1 is the starting point of the request to the server okay so when server receive T2 it doesn't mean that server is T2 but client is T2 client don't know okay because just remember that this two machine is not in the same place okay if you are here you don't know the clock here okay if you are here you don't know the clock here that's why you need to calculate okay for example like if now is T2 but client don't know if the server is received at T2 or not okay and then certain needs some kind of time in order to send the request back okay so that time we call it T3 okay so here is T3 okay so when it's sending the request back we have T4 okay so now when the client send it send also T1 to the server and then when server send back server need to send T1 T2 and T3 okay so now client want to know like what are the time from T1 to T4 like what are the time spent in order to send this request go and then coming back so go and coming back we call it a round trip okay so if you go and don't come back it is a single trip okay so if you go and come back it is a round trip so client want to calculate these times for example like what are the time from when client send request to the server and it coming back okay so if the client start at 0 the round trip for example like T4 what are if we don't care about the server what is the time of the round trip ឧទាហរណ៍ថាឥឡូវអា T0 នេះគឺ0វិនាទីអូខេចាត់ទុកថាវា0វិនាទីចុះអញ្ចឹងពេលដែលវាទៅហើយវាមកវិញហើយបើយើងកុំខ្វល់ពី server តើអាពេលវេលាដែល client ផ្ញើទៅហើយផ្ញើមកហ្នឹងវាស៊ីអស់ប្រហែលមានអ្នកគេដឹងអានេះដូចរៀនមេរៀនរូបវិទ្យាហើយមេរៀនមក so for example like here is a T diagram okay T time is going from here so here is the starting point so I delete this one so for example like time starting from here down to here okay and then here is 0 second or 0 millisecond okay so when client send something and then coming back now it is here okay now it is T4 if we don't count the delay of the server we just count client go and then coming back what are the time that we spend for a request to go and coming back hiện ở tầng một cái ngày nàyដឹងអត់បានន័យថាយើងចាត់ទុកថា T0 នេះគឺ0ចាត់ទុកថាម៉ោង0ម៉ោង0ក៏ដកសញ្ញា00វិនាទីតទៅពេលយើង send request ទៅ server ហើយតទៅពេលឥឡូវយើងទទួលបាន request មកវិញនៅអាម៉ោងប៉ុណ្ណេះអញ្ចឹងសួរថាតើពីមកទៅហើយមកវិញហ្នឹងវាស៊ីអស់ប៉ុន្មានវិនាទីបើយើងគិតអានេះជាវិនាទីចុះស៊ីអស់ប៉ុន្មានវិនាទីអត់មានអ្នកគេដឹងទេ ប្រឡង logic ធ្លាក់នេះអានេះអត់មាន technology អានេះគឺការគិតសុទ្ធសាធហ្មងបើន័យថាការស្វែងយល់សុទ្ធសាធហ្មងបើន័យថាយើងចាប់ផ្ដើមពីម៉ោង 0 ហើយតទៅពេល request ផ្ញើទៅហើយវាត្រឡប់មកវិញនៅម៉ោងប៉ុណ្ណេះអញ្ចឹងសួរថាតើពីផ្ញើទៅឲ្យផ្ញើមកនោះស៊ីអស់ប៉ុន្មានម៉ោងប្រើពេលវេលាប្រហែលអត់ឆឹងតោះសុកកញ្ញាមានដឹងអត់ What is the time that need for a client to send request and coming back without counting this one
ប្រហែលជាមួយវិនាទី
មកវិនាទីតោះមិញណាគេឆ្លើយត្រូវហើយផុសឆ្លើយដល់ទៀត
second
Yes T4 ព្រោះអានេះយើងមិនរាប់វាថាមួយ second ណាចឹងយើងអត់ដឹង second ទេដោយសារធម្មតាយើងត្រូវតាមតាកណិតពេលខ្លះគឺគេអត់គេហៅអត់រាប់អាលក្ខណៈបែបគេហៅ instant ណាគេហៅបែប variable មូលហេតុហ្នឹងហើយបានគេតាំង T1 T2 T3 តោះណាតទៅពេលចឹងបានន័យថាពេលដែលយើងឆ្លើយវិញក៏យើងត្រូវឆ្លើយជា T1 T2 T3 ឬមួយក៏ T1 ដក T2 ឬមួយក៏អីដែរអាហ្នឹងគេបានគេហៅកណិតតោះណាចឹងមានន័យថាពេលវេលាវាចាប់ផ្ដើមជាង T1 យើងចាត់ទុកថា T1 ហ្នឹង0ចុះអញ្ចឹងមានន័យថា T1 ហ្នឹងហើយ0ហ្នឹងវាស្មើគ្នា T1 ក៏ដូចជា0 0ក៏ដូចជា T1 ដែរតោះណាតពេលហើយវាផ្ញើទៅហើយវាផ្ញើវិញអញ្ចឹងបើយើងគិតមើលម៉ោងហ្នឹងវាដើរទៅរហូតម៉ោងហ្នឹងវាទៅទឹកអញ្ចឹងទៅមកដល់កន្លែងនេះឧទាហរណ៍ថាម៉ោងនេះគឺ client send ទៅណាហើយ site client ហ្នឹងវាកំពុងអង្គុយចាំពេលណាមកវិញទឹកស្រាប់មកដល់កន្លែងនេះពុបអូមកដល់បាត់ហើយនេះវាមកដល់ហើយនេះតោះណាអញ្ចឹងសួរថាពេលវេលាហ្នឹងចំណាយអស់ប៉ុន្មានគឺចំណាយអស់ T4 នេះព្រោះដោយសារយើងអត់រាប់អានេះណាតិចទៀតយើងរាប់បានយើងយកវាទៅដកបូកប៉ុន្តែឥឡូវយើងចាត់ទុកថាយើងអត់ខ្វល់ទេចាត់ទុកថាហ្នឹងវាបើសិនជាយើងនិយាយពីកណិតគេហៅអាច negligible អាចចាត់ទុកថាហ្នឹងស្មើ0ណាអញ្ចឹងនាំឲ្យម៉ោងហ្នឹងគឺវាស៊ីអស់ T4 វិនាទីព្រោះបើយើងគិតអានេះជាវិនាទីតោះណាបើគេគិតជា millisecond អានេះគឺអស់ T4 millisecond អញ្ចឹងទៅបើគេគិតជា microsecond អានេះវាអស់ T4 microsecond អញ្ចឹងទៅតោះណាតែអ្វីដែលយើងចង់ដឹងគឺបានន័យថាម៉ោងពេលដែលទៅឲ្យមកវិញគឺពី T1 ដល់ T4 ហ្នឹងគឺស្មើនឹង T4 ហើយបើសិនជាយើងចង់ទៅសេរូបមន្តស្រួលទេម៉ោងហ្នឹងគឺ T4 ដក T1 ត្រូវអត់ហើយតទៅពេល T1 យើងស្មើប៉ុន្មាន T4 ដកប៉ុន្មានតោះម្នាក់ផុសមិញដឹងឈ្មោះអីអត់ដឹងឈ្មោះអីជួយប្រាប់មើល
ដក0ចឹង
ហ្នឹងហើយត្រូវហើយព្រោះដោយសារយើងចាត់ទុកថា T1 ហ្នឹងវា0អញ្ចឹងវា T4 ហ្នឹងដក0អញ្ចឹងនាំឲ្យចម្លើយគឺ T4 ឃើញលំហាត់មហាស្រួលទេយល់នៅតែបើសិនយូរដល់ឥឡូវ T1 នេះគេចាត់ទុកថា2វិនាទីចុះហើយវាមកដល់5វិនាទីអាហ្នឹងមិនយើងថាយក5ដក2ទៅវានាំឲ្យអាពេលវេលាដែលផ្ញើទៅផ្ញើមកហ្នឹងវា3វិនាទីតោះណាតែអានេះដោយសារខ្ញុំឲ្យវាស្មើ0ណាតែបើខ្ញុំអត់ឲ្យវាស្មើ0ទេពេលវេលាគឺស្មើនឹង T4 ដក T1 យល់ប៉ុណ្្នឹងអត់ So if I consider I assume I suppose that T1 is 0 the round trip is equal to T4 without calculating T2 and T3 okay because T1 is 0 so T4 minus T1 so round trip is T4 minus T1 T4 is the receive the response time and then T1 is sending the request time so this is the send and then this is arrive okay so when it arrive we use arrive minus send is so normally if T1 is not 0 the round trip is T4 minus T1 but I suppose T1 is 0 so the round trip is T4 យល់ប៉ុណ្ណឹងទៅមុខទៀត understand so now let coming back now we done now T1 is not we not suppose T1 is not 0 we suppose T1 is T1 okay so that's why there are some formula to calculate and then we do not suppose that this one is negligible we suppose that this is T2 and then this is T3 okay so how do we calculate the round trip okay so if we want to calculate the round trip so we know that the total waiting time of the client is T4 minus T1 okay because T1 is not 0 so now we have this time so T1 minus T4 is this one okay this one from here to here but we also need to remove this one because we don't want to count the server processing time okay we only want to count the request time from here to here and then from here to here that's why we need to minus this little space okay so this little space is T3 minus T2 okay And then this formula we call it a round trip network delay time. So when you go to see here, the network round trip network delay is T4 minus T1 is this one, and then T3 minus T2 is this little space, and then when you use this one divide by minus this one, we call it a round trip time. So this is the first formula. Chẳng vôรูปมนต์ទី1nữa. រូបមន្តទី1គេចង់ថា request ហ្នឹង send ទៅឲ្យមកវិញ see អស់ប៉ុន្មានម៉ោងហើយគេអត់ចង់រាប់អាម៉ោងដែល server វាធ្វើការឯតោះនេះចង់ដឹងថាពីនេះមកដល់នេះប៉ះប៉ោកហើយពីប៉ះហ្នឹងចេញមកវិញតើប៉ុណ្ណឹង see អស់ប៉ុន្មានម៉ោងហើយអាទៅឲ្យមកហ្នឹងគេឲ្យឈ្មោះថា round trip network round trip delay តោះនេះបានន័យថា client ត្រូវរងចាំប៉ុណ្ណឹងបើទោះបីជាវារងចាំរហូតដល់ T4 ក៏ដោយក៏តែបើសិនជាគេអត់រាប់ប៉ុណ្ណេះទេវារងចាំតែ T4 ដក T1 ដកនឹង T3 ដក T2 ឯង understand យល់ទេតោះកញ្ញាយល់អត់
Yeah, teacher.
បើកញ្ញាយល់អ្នកផ្សេងទៀតដឹងតែយល់ដែរ Okay តោះឥឡូវ so this is the first formula. Okay, so round trip network delay we don't count the server processing time. Okay, so we only count client from client to server. So this is one trip and this is another trip. So that's why if we want to count only a single trip, it is equal to what? It is equal to the total time divided by 2. Okay, so round trip is this we call it sigma or less sigma, and then the single trip is sigma divided by 2. It's half of the sigma. Okay, អញ្ចឹងបើសិនជាយើងយកអារូបមន្តហ្នឹងមកនិយាយបានន័យថាយើងបើសិនយើងយក T4 ដក T1 ដក T3 ដក T2 នោះវាញ៉ៃញ៉ៃពេកគេតាំងអាទាំងអស់ហ្នឹងជាអក្សរមួយតួព្រោះកណិតចូលចិត្តអញ្ចឹងចូលចិត្តឲ្យតែអីញ៉ៃញ៉ៃ suppose ឲ្យវាទៅជាអក្សរមួយហ្នឹងទៅអញ្ចឹងនាំឲ្យអក្សរមួយហ្នឹងគេឲ្យឈ្មោះថា network delay ហ្នឹងគឺអាទៅឲ្យមកតទៅពេលបើយើងចង់ដឹងតែទៅឬមួយក៏ចង់ដឹងតែមកទេយើងយក average របស់វាទៅគឺយកវាចែកជា2តនេះយកអាហ្នឹងចែកជា2ទៅគឺទៅឬមួយក៏មកអូខេ So now the second formula, estimate server time when client receive the response. So y is T3 plus the average, plus the halfway, okay? So for example, like when the server, so now server is T3, okay? Here is T3, server is T3. But server also need to wait some amount of time when the client receive it. So what are the time that server need to wait? In order for the response go back to the client. Okay, so what are this time? Like this one. What are the time between this T3 and this one? Miền nào kia đắng? Bạn này thà server ពេលវាផ្ញើ response មកវិញគឺវាម៉ោងវា T3 ក៏តែវាត្រូវរងចាំរហូតដល់ពេលមួយនេះរហូតដល់អានេះដល់ T4 នេះដែល response ហ្នឹងមកដល់អា client ហើយគេចង់ដឹងថាតើនេះអាម៉ោងប៉ុណ្ណេះម៉ោងប៉ុន្មានហើយតើនេះឥឡូវសំណួរសួរថាតើ client ត្រូវ server ត្រូវការរងចាំប្រមាណនាទីប្រមាណវិនាទីហើយបើយើងនិយាយរូបមន្តប្រមាណមានតែគេដឹងឯងនេះអាប៉ុណ្ណេះប្រមាណហ្នឹងប៉ុណ្ណឹង So who know what is the time between here to here? មិញណាគេឆ្លើយត្រូវឈ្មោះគេផុសតែឆ្លើយត្រូវមុនឈ្មោះអីបើក voice តិចមើល
ខ្ញុំពន្លឺ
អូខេពន្លឺឥឡូវពន្លឺច្បាស់ទៀតអត់បើសិនជាយល់មិញបានតែយើងយល់តិចឥឡូវយើងយល់ទៀតអត់ថាតើ server ពេលវាផ្ញើមកគឺវាម៉ោងវា T3 តទៅពេលវាមកដល់អា client នេះ T4 ក៏តែយើងអត់ចង់សួររឿង client ទេយើងចង់សួររឿង server ថា server ហ្នឹងវាត្រូវរងចាំពេលប្រមាណដែល request មកដល់អា client នេះម៉ោង T4 នេះ
អត់សូវច្បាស់
ហ៎ក៏តែបើយើងគូសវាឲ្យវែងយើងគូសវាឲ្យវែងមកបានន័យថាវាត្រូវការចំណាយពេលប្រព័ន្ធនេះអាប្រព័ន្ធវា coming back នេះតោះណាយើងដឹងថាអាទៅវាមិនស៊ីពេលប្រព័ន្ធនេះត្រូវអត់មកវិញវាមិនស៊ីពេលប្រព័ន្ធនេះត្រូវអត់ចុះអាទៅហើយនឹងអាមកហ្នឹងរូបមន្តវាគេមិន sigma ត្រូវហ៎ក៏តែបើយើងចង់ដឹងតែមកមិន sigma លើ2ត្រូវអត់ហើយតទៅពេលយើងចង់ដឹងថាម៉ោងនេះឥឡូវ server ម៉ោងប៉ុន្មានហើយមិនអា T3 នេះអាពេលដែលវាចេញទៅហើយនឹងពេលដែលវាចំណាយអញ្ចឹងវាមិន T3 បូកជាមួយនឹង sigma លើ2យល់អត់
OK vô
Nhớ lên. Về chấm dương ắt vô nó để sao dương sao cần đó thì. Đó đấy, bờ sân về cần đó dương hiện cua xăm rùm bờ khô ba dương hiện kháng lùm hạt nâng về ắt sơ chỉ kháng này. Đó đấy. Hãy kết tích cùng dương cùng áo bột đo hay sigma thi ấy nâng thừa dương vậy nhé. Dương chặt túc thừa nâng ở easy với nhóm gọt sao cần đó để tại tàu bây dương hiện xoay vô tới chứ dương vô lại. Ok. Again, T1 when it come back here it is T2. Okay. When it going back here it is T3 and then it is T4 is here. Okay. So when it go here and then coming back, so we call it a round trip. Okay. Round trip. Okay. So what is the formula of round trip? We just write one single formula. Okay. So if that similar that formula is very difficult, just say it anything, because mathematics we can call it anything. Just say it air. Air is a round trip time. Okay. Go one and then coming back. Okay. So if I only want to count one, like from client to server here, from T1 to T2 or from T3 to T4, what is the time? Is round trip over 2. Okay, because go and back is air, so just go or just coming back is air over 2 or over 2. Okay, understand? So now like the server is on T3. Okay, we want to know what are the time here is the what we want to know. Okay, so what are the time here if we want to write in formula? If we write T4, it is not correct. Because why? Because the clock in server is not really equal to the clock on the client. So that's why when we want to calculate the time, we need the clock within the local clock. Okay. So we know that when it starts to send the response, it is on T3. Okay. So it needs to wait this amount of time in order for the client to receive. And the amount of time is waiting is the amount of returning. Okay. So returning only half of the round trip. So that's why the time that the server need to know the client receive the response is estimate to T3 plus the round trip over 2. That's why you see that estimate server time when client receive the response is T3 plus round trip over 2. Vô nữa, vô rồi một TP nữa. So here is T3 and then this position is T3 plus round trip over 2 and it is approximately equal to T4. On the T4 is on the client side. Okay. So if you go to look at the client, it may be T4. But when you go to see the clock on the server, it is T3 plus round trip over 2. Okay. And this T3 plus round trip over 2 and T4, it is very, very close to each other, but not exactly, because time has error. Time is not perfect. Clock is not perfect. Toán. Tao hỏi là khéo pi phần lư hay cả nhà nẹp xây tiết vô lọt. Vậy là dương nhông phải chỗ piรูปมนต์này.รูปมนต์ round trip hay năng รูปมนต์ mount នៅលើ server នៅពេលដែល client ទទួលបានចម្លើយ. Đó. Understand? Please say yes. Cả nhà and phần lư may understand. How about the other? Ở đâm vô lọt ở đâm. Ở đâm đà ra cả đa. Phần này vì chia vô lọt. Còn sợ nó sợ chẳng cháo rồi mới có mau bị internet nhom slow sẽ lấy khó ta đầu. Ok, chẳng nhớ lên á. Ta hả lấy châu đà tí bay mấy nhờ bà hai chị là cái xua mấy bà hai chị bà nhà xua tại tao mà tí buồn nè. So now you understand the two formula. Let's see the last one. The last one is we want to know what is the different okay here. So now the last one we want to know what is the difference between T4 and this point. Okay, so now let's forget about T1. We don't want to know about T1. We don't want to know about T2. We don't want to know about T3. Okay. We want to know only this part. Let's put blue. So we want to know this time. We want to know here. Okay. So here is a time from 0 from the starting point to here. So now we want to focus on this time. So if you see it is on the client side, it is T4. Okay, client is T4. But if you go to look at the server, it is T3 plus or over 2. Okay. We want to know what are the error. So you can see that the formula is related to clock skew. So clock skew means error. So what is the error possible among T4 and T3 plus or over 2? Okay. So in the formula, you can see that T3 plus round trip over 2 minus T4. So we use the time on the server minus the time on the client. Okay. T3 plus or over 2 round trip over 2 and then minus T4. Okay. So for example, like if we use this time minus this time and then the result is equal to 0. What do it signify? What does it mean? នៅពេលដែលយើងយកអាម៉ោងនេះព្រោះឥឡូវយើងចង់ focus លើអាម៉ោងប៉ុណ្ណេះបានន័យថា server វាម៉ោង T3 បូក A2 តទៅពេលអា client ពេលដែលយើងមកមើលវាគឺអា T4 ឥឡូវយើងយកអាម៉ោង2នឹងដកគ្នាបើសិនជាខ្ញុំយក T3 បូក round trip លើ2ដក T4 ហើយស្មើ0មានន័យថាម៉េចវាអាចបញ្ជាក់បានន័យថាម៉េច If the clock on the server minus the clock on the client equal to 0 what does it mean? What does it mean? Arthur, can you answer? Arthur Portrell. If clock on the server minus the clock on the client it is equal to 0, what does it mean?
Then the clock have the same time.
Yes, that's right. So that means the clock on the server and the clock on the client, if you have live stream camera and then you go to use your live stream camera to view the clock on the server and the clock on the client, it is the same because normally it should be the same. Okay, T4 and T3 plus round trip over 2 should be the same if the clock is the same. Okay, but the problem is clock is not the same. That's why there are some error. Okay, and error we call it a clock skew. Okay. So here we represent the clock skew, this symbol data. Okay. So in the lecture you can see that data is the error. So how to calculate the error? So the error is this one. Okay. T3 plus round trip over 2 minus T4. So if it is positive, for example, like if it is 1 millisecond or 5 millisecond or 100 milliseconds, something like that. What does it mean? It means that the time on the server is faster than the time on the client. Okay. But if it is negative, like -1, -5, or -100, it means that the time on the server is slower than the time on the client. The time on the client is faster. Okay. So when we calculate data, which is a clock skew, the result could be 0, could be positive, or could be negative. Okay. យល់នៅអ្នកផ្សេងទៀតក្រៅពី author យល់នៅនេះបានន័យថាដើម្បី calculate អាភាព error ម៉ោងរបស់ server ហើយនឹង client ហ្នឹងនៅពេលដែលបើសិនយើងយកអាម៉ោងអា T3 បូក round trip លើ2ចែកនឹង4ហ្នឹងគឺម៉ោងនៅលើ server អានេះម៉ោងនៅលើ client តទៅពេលយើងយកវាទៅដកគ្នាទៅអានេះគេគ្រាន់តែចំនួនអានេះដល់អានេះអញ្ចឹងយើងមើលទៅឃើញរូបមន្តវាញ៉ៃតែតាមពិតដដែលគឺម៉ោង server ដកម៉ោង client តើណាអញ្ចឹងចម្លើយមាន3ចម្លើយមាន3let's say clock skew is equal to delta. Okay, so if delta is equal to 0, which means the clock on server and client are the same. Okay, so if it is positive, because we put the client clock first. So if it is positive, which means the client, the server is more than the client. Okay, so if the server is more than the client, which means server is the server clock is faster than client clock. Okay. If negative, client, or we can say server clock is slower than client clock. Okay. So that's why we have a three formula: round trip clock, the time when the server know that the client received the information, and then the difference of the time between the server and the client when the information received. Okay, so these are the three formula. Okay, you can go home and do the calculation again. You will understand more. Okay, so let's continue. So now we know about the data, the error rate. So in computer science, we define three kind of event that the developer or the administrator need to handle. If the speed of the data is less than 125 milliseconds, that means the clock will slow down or speed up. Not speed up or slow down. Yeah, speed up or slow down by itself. So 500 ppm is the speed of the vibration. Okay, so but because we use a certain kind of material and technology, so we can manipulate it. Okay, so if the clock is where is there some error rate, they will adjust the clock to speed up or slow down 500 millisecond. Not millisecond. These are the speed of the vibration. So ppm. You can search. I can search for you ppm. ppm clock speed. So what is ppm mean? So ppm mean it is a part per million. Okay, it is a normally it is a frequency of the vibration. So that is called ppm. So when there's an error of less than 125 millisecond, the clock will speed up or slow down 500 ppm. But if the error is more than 125 millisecond but less than 1000 second, they will modify the client clock immediately. For example, like the client clock and the server clock is different. So client clock need to define as the server clock. So you need to reset the client clock, okay? But it is done automatically. But if the error rate is more than 1000 seconds, so we call it a panic state, okay? So you have a slew, a step, and a panic. A panic statement, the computer will not do anything. It will just show you an error message, and then the human need to go to do something, okay? Because there might be some problem rather on the server or on the client side. So the computer will not do anything, and it will let human to modify the clock, okay? So that is the some operation that we need to do when there is some error rate less or medium or very high, okay? អញ្ចឹងបានន័យថានៅពេលដែលម៉ោងរបស់ computer របស់ client ហើយនឹងអា server នោះវាខុសគ្នាបើវាខុសគ្នាតិចតួចទេវាចេះ adjust ម៉ោងនឹងខ្លួនវាបានន័យថាវាធ្វើឲ្យអា vibration នឹងវាលឿនឬមកក៏យឺតតិចទៅហើយ5នាទីក្រោយមកនាំឲ្យ server client នឹងម៉ោងដូចគ្នាហើយតោះណាប៉ុន្តែបើសិនជាវានៅចន្លោះនេះទេបានន័យថាម៉េចគឺ client នឹងគឺបដូរម៉ោងទៅឲ្យស្មើនឹងម៉ោង server បដ ாய் បានន័យថាឧទាហរណ៍ឥឡូវ server ម៉ោង9 10នាទីអញ្ចឹង client ម៉ោង9គត់អញ្ចឹងទៅវាបដូរទៅម៉ោង9 10នាទីឲ្យដូច server ដែរដោយសារតែ error rate វាខុសគ្នាចន្លោះនេះអូខេតែបើសិនជាវា error ធំពេកគឺកុំព្យូទ័រនោះគឺវាអត់ធ្វើអីទាំងអស់បានន័យថាវានៅស្ងៀមហ្មងហើយឲ្យមនុស្សទៅកែវិញព្រោះអីវាអាចបញ្ហាមកពី server ឬមួយក៏បញ្ហាមកពី client វាអាចមកពី server ដែរអញ្ចឹងមិនប្រកាសថា server នឹងត្រូវអញ្ចឹងទុកឲ្យមនុស្សអ្នកទៅដោះស្រាយតើណាមនុស្សទៅកែម៉ោង server ហើយបានមកកែម៉ោង client វិញអញ្ចឹងទៅអូខេ So when the clock error happen we have three solution. If the clock error rate is very little, it will adjust itself by speed up or slow down 500 ppm, and 5 minutes later the server clock and the client clock will be the same, will be in sync. But if it's error between this one, the client clock will reset to the server clock. Okay, it will reset. It will request the time from the server and will reset it. But if the error is too big, because sometimes the server also has problem. Okay, so the error time is too big. We don't know what is the problem, client side or server side. So it let the human to modify. Okay, to go to see why there's so big difference. Okay. Okay, so we have a few more slides. So if you want, when you want to calculate the optimization speed of your algorithm, for example, like if I ask you to write one program, and then some of you write 100 line of code, some of you write 50 line of code, something like that, and then we want to compare which program is faster than another program. Okay, so if you use some kind of a method in the programming language, for example, in this case, maybe Java or whatever, if you just call the current time in milliseconds, something like that, it use the time from the network. So we call it a NTP client and NTP server. So you will encounter the problem when the clock, because a clock has 3 step of operation. Okay, so when you use this kind of method, you will encounter those kind of problem like speed up or slow down or reset or something like that. Okay, so normally when we write the code to compare the speed of the algorithm, we don't write we don't use NTP clock. Okay, we use another clock called monotonic clock. So what does monotonic clock mean? Monotonic clock is the clock in the local machine. Okay, it is not the clock from the server. It is not the clock of the NTP client. It is the clock when the computer is start. Okay, so in the code, it has a different function. One, for example, like this one is the current time milli, and then this one is a nano time. So if you want to calculate the speed of your programming, you call this method system.nanotime, not system.current time. Okay, so system.nanotime, we call it monotonic clock. It's the clock in the local machine. But if we use a NTP client and NTP server, we call it clock of the day. Okay, so you can see the definition here. Clock, the time of the day clock is the time which is fixed. For example, like we have in computer, we have one time called an epoch time. So epoch time is the number of seconds counting from January 1970. So have anyone ever heard about the epoch time? មានអាគេដែលលឺថាដែលលឺអាពាក្យ epoch time ហ៎ Anyone have ever heard epoch time before? ដែលលឺអត់ទាំងអស់គ្នាដែលលឺអាពាក្យហ្នឹងហ៎គេហៅម៉ោង epoch ហើយម៉ោងហ្នឹងគេគិតជាវិនាទីហើយគេចាប់ផ្ដើមរាប់វាតាំងពីខែ1ថ្ងៃនេះហ្នឹង1900ប៉ុន្មាននេះហ្នឹងតែមិញ Patrel you know?
Yes, it's the time in milliseconds from the January 1970.
Yes, it is the time from January like 1970. Okay, so if you want to know now, for example, like now is March 10 2022, and we want to know what are the epoch time. Okay, so you can go to see, for example, epoch time now, something like that. Okay, is there any real time here? So here we have time converter. Google didn't provide this. Okay, so now you can see that so today is 2022 March 1, now is a 1, so this may be an GMT. So when we use a local time, it may be different, and then when it is time, this is the number, we call it epoch time. Okay, so these are the timestamp in unit. You can see here. Okay, so here is the unique epoch time, and then you can see that it is always increasing. Okay, so in the computer, when you store some time, we don't store like that, like this. We only store this in the database, but even some database, they don't store this one, they store this one. Okay, ចឹងភាគច្រើនពេលខ្លះពេលដែលយើងធ្វើការ1ម៉ោងដោយថាយើងចង់ដឹងថា action មួយណាធ្វើនៅម៉ោងប្រហែលម៉ោងប្រហែលម៉ោងប្រហែលណាពេលខ្លះគឺយើងប្រើម៉ោងនេះថ្ងៃខែទៅ GMT ឬមួយក៏ UTC អញ្ចឹងទៅតែតទៅពេលអ្នកខ្លះទៀតគឺគេអត់ប្រើម៉ោងហ្នឹងគឺគេប្រើម៉ោងជាគិតជាវិនាទីនេះវិញតើណាអាហ្នឹងគេឲ្យឈ្មោះថា epoch time ហើយ Okay, so epoch time, we call it time of the day clock. It is since January 1st January 1970. It is also using NTP client and server. So it is subject to the 3 problem here. So it is subject to the problem of the error. So that's why the clock of the client and server need to adjust with each other in order to synchronize with each other. Okay, so when you want to call this epoch time in Java programming language, it is a system current time in milli. Okay, so in Linux is a clock get time, clock real time. Okay, and there is another time called monotonic clock. So monotonic clock is a time when your machine is boot up. So it is very constant. It doesn't has an error because it is locally. So we don't compare the clock to the other machine. So that's why we call a monotonic clock. And then in Java is a system.nanotime. And then in Linux you can call clock get time clock monotonic. Okay. So when you want to compare the speed in your programming language, you should use a monotonic clock. You should not use this one because this one they have to speed up, slow down, and sometimes they need to step adjust the clock. So when that kind of action happen, your program will not calculate the clock correctly. Okay. I think we can stop here now. We can the other slide we can talk later because this chapter is simple but also complicated a little bit. Okay. So any question related to the epoch time, time of the day, and then a monotonic clock? So monotonic clock is the clock in the local machine, and time of the day is the global time, is a epoch time, and then there is also some network time protocol that handle this kind of time. Okay. Question. So at least today you will learn that the way that we measure time is not perfect. Okay. It has some kind of error, and those kind of error produce some problem. The first problem, when your client machine and your server machine has different time, you cannot access to the service. Okay. And the other machine, the other problem is happen globally when the leap second happen. Okay. Leap second uh, new, for example. Let's see, is there any new of the leaps and major cycle down. Okay, so you can check this one is the inside story of the extra second that crash the web. Okay, so when there is a leap second happen, for example, like as I said, leap second happen on June 30 and December 31 because the time is not perfect. So when the time is not perfect, according to our lesson, we have three kind of example. So we need what do we need to do? We need to speed up or slow down the time. We need to step. So step means we reset the client to the server. So this step happen in a leap second. Okay, and then another one is a panic. So when the step operation happen, what is the problem? The computer crash because the time, some program that related to time has a problem because the time is not counting sequentially. It moving from, for example, like from 30 to 32 or from 32 to 31, something like that. So when the leap second happen, there is also a problem. So you can read some new in the internet related to the leap second. Okay, so the leap second could crash the whole internet if your internet doesn't count on those kind of leap second. Okay. ចឹងដោយសារតែម៉ោងហ្នឹងវាមានភាពវាមិនពិតប្រាកដវាមិនច្បាស់លាស់វាមាន error ចឹងហើយបានវាមានរឿងកើតឡើងបានន័យថានៅពេលដែលម៉ោងហ្នឹងវាចេះ load ដូចយើងនិយាយចឹងបានថាម៉ោងនៅពេលដែលវា error ដល់ពេលមួយវាត្រូវ load ឯនេះដូចថានៅពេលដែល error ហ្នឹងវានៅចន្លោះនេះគឺវាត្រូវម៉ោងហ្នឹងគឺត្រូវ load ហ្មងចឹងនៅពេលដែលម៉ោងហ្នឹង load វាបង្កើតឲ្យមានអា leap second កើតឡើងដល់ពេល leap second កើតឡើងហ្នឹងនៅពេលដែលកុំព្យូទ័រយើងឬមួយក៏ software យើងអត់បាន handle អាហ្នឹងទេគឺនាំឲ្យអា software ហ្នឹងគឺ down ហ្មងតោះនេះ server ក៏ down client ក៏ down service ហ្នឹងលែងដើរបណ្ដោយ ហើយបើយើងចង់ដឹងព័ត៌មាននឹងច្បាស់ទៀតយើងអាចទៅអាននៅលើអ៊ីនធឺណិតទៅតាក់ទងជាមួយនឹងរឿង leap second ហ្នឹង okay. So if you want to learn more about what are the problems caused by leap second, you can go to search some news on the internet. You will understand like what happened when the leap second happen. Okay. Okay, I think that's all for today. Please go back and review the lesson from lesson 1 to lesson 3 because some of you, when I ask the question, you still cannot answer. And then let's see you next week. Okay.